Page 100. All right, so now we're going to do this one the hard way. We're not going to use a chart, and you'll see why. So for this example, example number 2, astronomers on Earth observing a distant galaxy measure a visible light wavelength of the element hydrogen at 690.36912 nanometers. I went out that far on purpose, and you'll see why. Normally, this line is emitted at 383.5384 nanometers. So that would be lambda naught. So let's determine the recessional velocity of the galaxy relative to Earth. So we're going to calculate z. Always calculate your z first. So z, lambda minus lambda naught over lambda naught. This should be getting to be old hat at this point. We're just going to plug in the numbers. So 690.36912 times 10 to the negative 9 minus 383.5384 times 10 to the negative 9 all over 383.5384 times 10 to the negative 9. Okay, so now we know that these powers of 10 are going to cancel out, so we'll go ahead and keep this a little bit simpler. So that's going to give us 306.83072 over 383.5384. Okay, and that comes out to pretty close to 0.8. So that's my z. And if you look at that cheat chart, you'll see that we don't have an entry for a z, a redshift z of 0.8. So what to do? Well, we bash it out the hard way. Here's how we do it. V over c equals z plus 1 squared minus 1 over z plus 1 squared plus 1 equals 0.8 plus 1 squared minus 1 over 0.8 plus 1 squared plus 1. And then from here on in, it's just straight arithmetic. So this is going to be 1.8 squared minus 1 over 1.8 squared plus 1. That equals 3.24 minus 1 over 3.24 plus 1 equals 2.24 over 4.24 equals 0.528 C. There it is. Pretty straightforward stuff.